Alright, we're starting to talk about inequalities, okay, and how inequalities work. Well, an inequality simply means that you've got two little statements that aren't equal, but they are related, okay? Well, this is saying x plus 2 is greater than 4, alright? So what we want to know is what can x be in order to make this a true statement? Well, I look at it and say, well, can x be a 6? Well, yeah. 6 plus 2 is 8. That's greater than 4. Can x be a 20? Yeah. 20 plus 2 is greater than 4. Can x be a negative 10? No. Negative 10 plus 2 is negative 8. Okay? That's not greater than 4. So remember that when you have an inequality, the mouth is always trying to eat the larger number. Okay? And it's pointing at the smaller number. Okay? So what I want to do is I want to treat this in a lot of ways like an equation. Okay? So whatever I do to one side of an inequality, as long as I do it to the other, I'm okay. Alright, so what I'm going to do here is I'm going to subtract 2, subtract 2. Okay? So this leaves x by itself. So x is greater than 2. So as long as x is greater than 2, this is a true statement and we're good to go. I'm going to show you different ways of presenting that information in the next clip. But we're just going to work on how to solve these ones. Okay, so here, same thing, 3x, in this case though, is less than a 9. Okay? 3x is less than 9. So we want to know all the possible numbers, okay, that x could be to make this a true statement. And there's an infinite amount of them, it's just, but there are limitations. So here, all I'm going to do is divide by 3, divide by 3, okay, so 3's cancel. X is less than 3. Okay, so as long as x is less than a 3, this is a true statement. So x could be negative 6, x could be a 2, x could be negative 2,467,8. Okay? Now this one here, right, this is less than or equal to. Okay? So that means it could include this number. Back over here, when x is less than 3, x can't be a 3. Because if x is a 3, 3 times 3 is 9. 9 is not less than 9. Okay? So the less than or equal to sign is a little bit different. It means it could be equal to it. Alright, in this case, trade the same way. I'm going to subtract 4, subtract 4. 2x is less than or equal to 2. Divide by 2. Divide by 2. X is less than or equal to 1. Okay? So x could be a 1, and this could be a true statement. Okay? Or x could be anything less than 1 and be a true statement. Okay? So x has a pretty big range of possibilities, but x could not be anything greater than a 1. Now here's one that's a little bit more complicated. Okay, it gets treated the same way. Now this is greater than or equal to. Okay? So in this case, subtract 4, just like the last problem. That leaves me with negative 4x is greater than or equal to 12. Oops. Okay. So now I'm going to divide by negative 4, divide by negative 4. Now here's where this whole thing gets tricky. Whenever you multiply or divide an inequality by a negative, the inequality flips. Okay? So over here, the negative 4 cancels. I've got x. Okay, still got an x. But this inequality turns around. So no longer is it greater than or equal to, it becomes less than or equal to. And 12 divided by negative 4 would be a negative 3. So x needs to be less than or equal to a negative 3. So that's the tricky part. Whenever you have an inequality and you multiply or divide by a negative, the inequality flips. Okay? That's not add or subtract a negative though. You can add or subtract as many negatives as you want and it's not going to flip. It's only when you multiply or divide by a negative.